All right, welcome back. I saw from the chart, Dan initially had trouble with R. It said working now. Dan, would it be okay if we explain what happened? Other students may benefit because we have a couple of students have trouble using R. How did you troubleshooting your problem? Dan here? Okay.
I just re-downloaded it, the package again, and then deleted it and started over.
Wow, so you deleted original package, then reinstalled the package?
No. So it asked me, do you want to delete the previous one? And I said yes, and then I reinstalled it again.
Oh, thank you so much for sharing. Can you remind me your name?
It's Tamara.
Oh, Tamara, thank you so much.
No problem.
I appreciate. So maybe some other students, if you have similar trouble, you reinstall the package. If asked you delete the original one, you say yes, reinstall the package should solve the problem. Thank you so much for sharing. Okay. All right, any other questions? Wow, great. I'm so impressed. You guys are great troubleshooter. Okay, that's great. Thanks for sharing. So before the break, we created a model. We test the model is appropriate. Finally, we forecast the future value using the model. That is the before break. So now we move on to next slide. Next slide. So what we are going to do in this slide, yeah, we forecast. Autoplot. So we did that actually, slide 11. Move on slide 12. Another way to see the forecast, you can type in this command. Again, this is not available in the textbook. So you can try summary, then fcast. You get this result. Okay, so let's try this command. Summary, fcast. See, you got all the information, including the model parameters, okay, and the forecast value. So this is another command, summary. So slide 13, use another example. So we finished the example for US change. So this example will use electricity daily demand. So this data, in this data, we have a work day. So a week has Monday to Friday as work day. If it is work day, we use number 1. If it is non-work day, we use 0. Okay. So how the data looks like? This is how this data looks like. It has demand. It has the work day, 1 represents work day, 0 non-working day, and it has the temperature. Okay. And how do you get this data? You go to next slide. You type in this command, view elect daily. For those students, you have your R available. You can follow this example. It has nothing to do with the example we did before. You can follow this example. So everyone, if your R Studio is working, you can use this example. So in the command line, you just type in, I do not have text to copy. Yeah, it is, okay, not text. So you just type in view bracket elect daily case sensitive. Okay. So view elect daily closing bracket, press enter key, and you get this data here. Okay, so you get an idea how this data looks like. How many records in this data? If you scroll down, you can check. There are lots of data here. Hundreds of data, 365 means it is this is for every day. 1 year has 365 days. Okay, so 365 observations in this data. And once we get an idea, so this data have demand, workday, temperature. We want to take a look at the demand, okay, to create a sequence chart. In SPSS, it's called a sequence chart. So demand is in the first column. So we just use this command, auto plot, elect daily, then use square bracket, comma, 1 means the first column. Okay, so again, let's type in this command. Auto plot, elect daily, square bracket, comma, 1, column 1, closing square bracket, closing rounding bracket. So type in this command. When you press enter, see the graph is showed here. Okay. So it has ups and downs. So this is a create sequence chart for demand column. For demand column, we get an idea. And next, let's create a sequence chart for the temperature. For temperature. Temperature is in the third column. So you go back to R. Because these two commands are similar, if you want to avoid retyping the command, you press on your keyboard, you type in the upper arrow. That means you repeat the previous entry. And just change this number 1 to number 3. So you want the sequence chart for temperature. Press enter. So this is the temperature, okay, for temperature. So we get an idea of how the temperature and demand sequence chart looks like. After that, we create a model. We create a model. This model, Y is our demand. Okay, demand is our Y. X is, there are 3 X. No, temperature. Yeah, 3 X. The first X is temperature. The second X is temperature square. Why we need temperature square? Remember when we create the graph for temperature, this is the graph for temperature. It's like sometimes it has the quadratic component, So that's why in our model, we want to include temperature square. So this is our second X. And then the third X is the work day. So we have 3X, temperature square, and work day. And which one is my Y? Demand is Y, dependent variable. Y, independent variable has 3. Okay. So we want to fit this model. And you have, do I have the, yeah, I have the command line here. So you just copy this, hope it will work. If not, I have to copy from Word document. So define X variable by copy this, right click your mouse. I do not have copy, maybe just Control C. And then go to my R, Control V. Didn't response. I'll Control C again. Home, copy button, and then Control V. Okay, now it is working. Hope when I press enter. Yes, it is working. So I define my X has 3X. That is my X. So just copy and paste from PowerPoint this command. After that, once you define your X, you fit the model, okay, using ARIMA. So this, quick copy, fit, copy, and then Control V, fit. Okay, so it is working. Okay, I fit the model. But what is the model looks like? What is the model looks like? Before that, let's check the residue to see if the model is good. So type in this command, check residues, bracket, fit. So this is the result after I type in check residue. From the graph, the residue is normal distributed. That is good. But the ACF has one big spike here. Okay. So that is the data residue called us. And the model name, you also get the model name. We use this model, ARIMA 212 and then 200. The first bracket, 212, is the regular ARIMA. The second bracket, 200, is the seasonal part. Okay. And we get our, yeah, this is the residue. Check the residue information from there. So after that, now we need to do the forecast. Okay. So what we want to use the model to forecast 14 days ahead, starting from Thursday, January 1st, 2015. Okay, so that is what we are going to do. When you do the forecast, remember we have 3X for this model. The first X is temperature, second X is temperature squared, the third X is the work day. For the temperature, when you do the forecast, we need to check the weather weather bureau to see the forecast for the next 14 days. But for this example, we just set the temperature for next 14 days to be a constant of 26 degrees. Okay, this is the assumption we have made. Use a constant 26 degrees as temperature. So this data is seasonal data. Okay, it is weekly data. So that's why this is 7 is here. And this ARIMA get from, remember when we type in residue, we get this model name. So now we are going to do forecast for next 14 days. For next 14 days, okay? So you need to type in this command here. Hope it will work. Auto plot. So let's do one by one. Let's copy this command first to do the forecast. Okay. So copy, no copy. So I go to home, copy, and here, Control V. Okay, so I forecast, press enter. It said unexpected. Because I use copy and paste, some formatting appears. So I'm going to fix this. I will press the up arrow to repeat the command. Then I will delete. You see there's a dot, delete this one, and delete this dot. Hope this time will work. Press enter. Yes, it will work. So when you copy and paste, some formatting character appear. So you need to delete those. Okay. So after that, we auto plot the forecast result. So I'm going to type in this command, copy. So now copy. So I go to home, copy, and then paste. So I want to produce a graph. So this is the graph for forecasting. Those are the historical data. This part with the blue represent the forecast part. And the model is ARIMA 212200, weekly data. Okay. So this is the forecast result in graphical representation. Okay. And how do we see the 14 days forecast in numeric format? In numeric format, remember you can type in summary, fcast, summary, this format, summary, fcast, you get all of this result, forecasting. Okay, so let's do it in R. So summary, fcast. Okay, you get 14-day forecast here. Those are the 14-day forecast. Okay, so this is the electricity demand example. Next, you want to, so we finished that example. Okay, this stochastic and deterministic trends, this is a section 9.4. Okay. Usually there are two different ways to modeling a linear trend. One way is a deterministic trend. We actually use this a lot, but we don't give this name. It is actually the normal way we forecast modeling a trend. It has a name that is deterministic trend. Remember, if I type in this equation, it is familiar. So y equal to beta 0 plus beta 1 t, and then plus eta t. eta t is a Riemann process I explained at the beginning. So this is deterministic trend. Another way is stochastic trend. The format looks like, see, these two looks like the same, but in stochastic trend, eta t has a difference d equal to 0. That is the only difference between deterministic trend and stochastic trend. In stochastic trend, eta t is an Riemann process with d equal to 1. In deterministic trend, eta t is a Riemann process, I would type in with d equal to 0. Okay, so that is the only difference between those methods. What those two methods do, they model a linear trend. Model a linear trend. So now let's take a look at data, another data. This data is the data name is AUSTRA. So if you type in view, VREW view, and then AUSTA, you get a sense of what that data looks like. It is about international visitors to Australia. Okay, so let's take a look at the data by typing view AUSTA. View AUSTA. It is actually the number of visitors in maybe the unit in thousands of people or millions of people. Those are the data. Okay. So what are we going to do with this data? So let's go to the next slide. So we are going to create a model, okay, deterministic trend model. And how do we create this model? We issue two commands. The first command is trend, create, okay, and then use this trend as an X into a Riemann model. So let's do step by step. Copy this command to create a trend. Okay, once you define trend, then copy this command, fit1. Why we need called fit1? Because we want to have two models. One is a deterministic model. The other model is a stochastic model. Stochastic model is fit2. This deterministic model is fit1. So again, copy. If you put the round bracket inside the round bracket for the fit, it will give you the model result. Okay, so copy and paste. See, I also pasted this dot, so I delete those dot. Okay, without the period dot. Okay, so I get this model result because I have a parameter for AR1, AR2. Model name is ARIMA 200. Okay, and I also have the model criteria AIC, BIC. Okay, So how do I interpret this result? So first, based on this result here, you are required to write down the model. This is the solution. So the model name is ARIMA 2. Okay, this 2 means eta has something to do with t minus 1, t minus 2. Okay, and this intercept 0.4156 is like the B0 intercept. And this 0.1710 is like the slope. So yt equal to B0 plus B1t plus eta t. Eta t is the ARIMA error. So for eta t, you based on these two numbers, AR1, AR2. AR1 equal to 1.1127, see, 1.1127. This associated with t minus 1, eta t minus 1. And this negative 0.3805 is the parameter for eta t minus 2. And epsilon t is white noise, okay, with the mean standard deviation 0.03. Okay, so this is a 0.03, yes. So where this 0.03 coming from this output is sigma square. Sigma square is here. You put sigma square here. So this is the model, deterministic trend model. Okay, so make sure you understand this output. Okay, and be able to write down equations like this, the model. All right, so next, we are going to create a stochastic model. Okay, stochastic. Do I have command? Yes. Remember, stochastic model have difference equal to 1. So copy this command to create stochastic model. Okay, so copy and then paste. Press enter. Okay, so this is the result for stochastic model information. And how do we write a result based on this result? Okay. Remember, for stochastic, d equal to 1 means we need to use y minus yt minus 1. We need to use this. And then you have B0. B0, the R call it is a drift. Okay, it is actually the intercept. So B0, so 0.173. Okay, and then plus eta prime t. Okay. So this is the model. This one equation is the equivalent of these 3 equations. These 3 equations. So the first equation is this one, and it is detailed about eta t with connection with eta t minus 1, and also the error term. The coefficient can be found here. The coefficient. And the epsilon t is the white noise. Mean is 0. Sigma square is 0.034 here. And it also gives you the AIC, AICC, BIC. Okay, so AIC is first order estimate. AICC is the second order estimate. Okay, so we created these 2 models. Okay. And if you compare these 2 models, which one you want to use, maybe you can compare the BIC or AIC with the first model. Okay. So that is the model we created. we created. And next, how do you create a chart? So this is a longer format command. So I'm just going to copy and paste. Copy, and then go to the R, paste, press enter. Okay, so this allow you to make a forecast. The pink color represent the forecast result for deterministic trend, and this blue using the stochastic trend model. And over here is the original data. Okay. So this is to do the forecast. So we did that. This is just a screenshot. Okay. So that is a 9.4. Okay. Now let's move on 9.5, dynamic harmonic regression. Okay. This one, when we use the harmonic regression, if we have a seasonal pattern using Fourier terms, Fourier term is the sine, cosine, okay, sine curve, cosine curve, okay, using Fourier terms with the short-term time series. So what we are going to use, the data is Cafe from 2004 to November 2016. We are going to forecast 24 months ahead. When we use Fourier, the sine, cosine pairs, we use K represent how many sine, cosine pairs we are going to use. So this is the brief introduction about the dynamic harmonic as well as the data we are going to use. So next, again, this is not in the textbook because when I try to run the code, I have some problem, then I troubleshooting to get the problem fixed. The thing is, you have to install Grid Extra in order to get the following code to run. Okay, how do you install this Grid Extra? You go to R, and over here you have packages, and then you type in install, and then you type in Grid Extra. That's it. Then click install. I already installed it, so I do not click install button. So I give you a few moments. If you want to follow this example, you need to install Grid Extra. This is our graphic interface. And for this dynamic harmonic regression, it is involving actually some programming techniques. For example, the for loop, for I in blah, blah, blah. It is the basic structure in any programming languages. We introduce the for loop here. You don't need to understand this code, but you need to know what this code does. Okay, what it does. So let's see. Then explain what this code. So I will just copy the whole thing and paste it into the R. Press enter. And it will take a long time. I don't have any error message means that is okay, but it takes long time to have the graph coming out. Maybe I will show you here. The graph you will get is here. This is the graph after copy and paste the command. You will get the different situation, okay, from k equal to 1 to k equal to 6. Remember what is k? K represents number of pairs for sine and cosine. When you have k equal to 1, you have this ARC negative 562. When you have k equal to 2, you get negative 636, etc. Remember, we need ARC, the smaller, the better. So out of this 6 situations, we have 6 situations because in the code, we have for loop. We want to loop 6 times. Each time we change k. And this is the result of the for loop. We need to pick up at the smallest AICC. So which one you would pick? Remember, this AICC is negative number. So the smallest will be k equal to 5. If you argue, we have k equal to 6, also even smaller than k equal to 5. But the thing is, the smaller, the simpler, the better. Okay, k equal to 6, you have to run 6 pairs. K equal to 5, just 5 pairs of sine and cosine. And those two numbers very similar. So we choose k equal to 5 based on AICC criteria. Okay, this k equal to 5. Once we decide k equal to 5, then what? We are going to is this this is another example. So once we have k equal to 5, we decide this is another example. So we get our model. Before we say, okay, maybe k equal to 1, k equal to 2, but finally we choose k equal to 5. Okay. So this example, we are running out of the time and realize maybe I will leave this example as the to read by yourself. It is a lagged predictor, but I will explain the overall principle here. In some situation, for example, TV advertising and insurance quotations, if you do advertising, the effect of the advertising will still take effect after the advertising ends. So that is the lagged predictor, okay? And the data we are going to use is insurance, INSURANCE. This is the name of the data. If you type in view insurance, you will get this data, how this data looks like. It has the codes, it has the TV advertisement, okay? And once you have those data, you can create a sequence chart for the codes and for the advertising. It looks like when the advertising goes up, the cost also goes up. This makes sense. You spend more money on advertisement, you will get more people apply for your insurance. Okay, so this is just a sequence chart. And then we are going to use lagged predictors, okay? So lag 0 means no lag, then lag 1, lag 2, lag 3. Okay? And then we are going to create 4 different scenarios or 4 different models. And based on these 4 models, we choose AIC criteria. And the second model is the best because the second model provides the smallest AIC. Okay, so which one is second model? This one here, like 1. No, this is this one here. Okay, will produce the smallest AIC. Okay, and you can copy this code into the R, and you get this output. Based on this output, you can write down the equation. Okay. That's conclude today's lecture about using R to do the ARIMA model. Okay, including the variable X, and X could be 1X, 2X, 3X, etc. Okay. Thank you so much for your participation. Thank you for being so patient with me for the last minute. And next week, we'll do chapter 11 in the second textbook, Advanced Forecasting Technique. Okay, and if you have questions, please email me because we are running out of the time. I'll try my best to answer your email. Thank you so much. Good night. Stay safe. I will see you next time.
Thank you, Dr. Fu. Have a good night.
Thank you so much.
Thank you, Professor. Professor,
Yes.
will you go through like the final exam outlines for the next week?
I will give you a list of final review, maybe not in, depending on if we have time or not. Whether we have time or not, I will give you the list, post the list on the D2L, okay?
Okay, so next week will be the last lecture, right? Before the final.
Correct. Next week is the last live lecture before final, correct.
Okay, and the final exam, it will cover from the chapter 1 to the chapter 11 from the second textbook.
Focus on whatever after test 2. Focus on whatever after test 2.
Okay.
I will give you the list. I will tell you the focus, okay?
Okay, thank you.
Yeah, you're welcome. Thank you for your question, Jay.
Professor, sorry, quick question. I won't take much of your time here. I was just wondering, when you're picking the model, do you pick based on the smallest AICC or AIC?
Doesn't matter. That is a good question.
Okay.
But you have to be consistent. If you compare AICC, you compare all AICC. If you compare AIC, you compare all AIC. To be consistent, you will get the same conclusion. Doesn't matter, AIC or AICC.
Okay, thank you so much.
Thank you, Matthew.
Have a good evening.
You too.
Professor?
Yes.
You know how we kind of ran out of time to finish off here?
Yeah.
Maybe you could record the rest, the last bit, and post on D2L.
Can you repeat the question? Sorry, Dan.
Yeah, for sure. So, and because we ran out of time and we weren't able to finish the example, maybe you could record it, Dr. Fu, and post it on the D2L or your YouTube page so we could see it with your example.
Okay, but the one we are running out of time is one reason. Another reason, the slides toward the end are not that so important. So
Okay.
don't worry, okay?
Okay, got it.
So
Okay,
because
thanks,
I just
Professor.
did overview, I will not test much in the final exam. Just
Okay, got
focus
it.
on, I give you the detailed explanation. The one I go overview, the last few slides are not that important, okay?
Okay, thank you.
You're welcome. Thank you, Dan.
All right, take care. Bye.
Bye. Okay, last minute question. Okay, thank you again. Good night.